You water your garden every single day. You are doing everything the books and the blogs and the little care tags on your transplants told you to do. And somehow, your tomatoes are splitting, your lettuce is bolting, and your pepper plants look like they are giving up on life. Here is what is actually going on. The advice you have been following, water a little bit every day, keep the surface moist, stick to a schedule, is scientifically wrong. And it is not just a little bit wrong. A University of Maryland study found that plants watered with shallow, frequent irrigation developed weaker roots, more thatch, and needed more than twice as much water compared to plants that got deep, infrequent soakings. You have been spending double the water to grow half the plant, and once you understand why, you will never water the same way again. Let me show you what is really happening underground when you turn on that hose. Think of your soil like a bank account. Every time you water, you are making a deposit. Every time your plants drink and the sun evaporates moisture from the surface, that is a withdrawal. The goal is to keep the account in a healthy range, not overdrawn, not so stuffed that the money is just sitting there doing nothing. Now here is where it gets fascinating. Your soil holds water in three completely different ways. The first is gravitational water. This is the water that floods through the large pores and drains straight down after you irrigate. It moves fast, it does not stick around, and your plants barely get a sip from it. Think of it like pouring water through a colander. The second type is capillary water. This is the good stuff. It clings to soil particles and fills the tiny spaces between them, held in place by surface tension. Your roots can actually pull this water out and use it. This is the water that feeds your garden. The third type is hygroscopic water. This is a microscopically thin film bonded directly to each soil particle at pressures up to 10,000 times atmospheric pressure. Your plants cannot touch it. Even a clay soil sitting at permanent wilting point, where your plants are literally dying, still contains 15 to 20% water by volume. There is water everywhere, and the plant cannot access a single drop of it. So when you water lightly every day, you are only filling that top inch or two with capillary water. Below that, it is still dry. And your roots have no reason to grow any deeper because everything they need is right at the surface. But here is the problem. That top inch is the most dangerous place for roots to live. It is the first zone to dry out on a hot day. It is where temperatures swing the most wildly. And on a sunny afternoon in July, 55 to 65% of that shallow water evaporates within just 4 hours. You are basically watering the atmosphere. And here is something that makes this even worse. When you water shallowly, the wetting front, that boundary between wet soil and dry soil, only moves down an inch or two before it stops. Below that line, the soil is bone dry. Your plant sees a tiny wet layer on top and a desert below. Where do you think the roots are going to grow? Now the type of soil you have changes this picture dramatically. In sandy soil, water drains through so fast that a shallow application barely wets anything before it is gone. Sand holds the least plant available water of any soil type, roughly half an inch per foot of depth. So in sand, shallow watering is practically useless. In clay, the opposite problem happens. Water infiltrates at barely a tenth of an inch per hour, and if you overdo it, clay holds water so tightly that it fills every airspace and suffocates your roots. And here is a wild detail. When clay dries out, it cracks. Those deep cracks act like express lanes for water, sending it straight past the root zone. Then the clay swells shut again and seals the surface. So your next watering sits on top and runs off. Loam sits in the sweet spot. It drains well, holds moisture generously, and reaches field capacity within about a day after watering. If you are working with sandy or clay soil, adding organic matter is the single best investment. A 3-inch layer of compost, mixed into the top 6 inches, can increase water holding capacity by 2.5 times in sandy soil. When you water deeply instead, say 2 inches of water that soaks down to 6 or 8 inches, you push that capillary water into the stable zone where temperatures are cooler and moisture barely fluctuates between waterings. And this is the part that really blew my mind. Your roots are not passive. They are actively hunting for water. Plants have a built-in guidance system called hydrotropism. When root tips detect a moisture gradient in the soil, they physically redirect their growth toward the wetter zone. And this response is so strong that roots will actually override gravity to chase water sideways or even slightly upward. Every plant species on land shares this ability. It is written into a gene called Ms1 that has been conserved for hundreds of millions of years. So when you water deeply, you are literally laying down a trail of breadcrumbs that guides your roots 6, 8, 12 inches underground. And a plant with 12-inch roots has access to a completely different reservoir of water than a plant with 2-inch roots. On a scorching day, the shallow plant wilts by noon. The deep-rooted plant does not even notice because its water supply is below the evaporation zone. But your roots do not work alone, and this is where the science gets really beautiful. About 80% of all plant species on Earth form a partnership with mycorrhizal fungi. These are microscopic fungal threads, just 2 to 10 micrometers wide, that weave through your soil and physically connect to your plant roots. Think of them like an underground internet, except instead of sending data, they are sending water and nutrients. A healthy mycorrhizal network can expand your plant's effective water absorption area by up to 700%. The fungal threads are roughly 100 times more efficient at absorbing water per unit of surface area than your roots are. A 2022 study from UC Berkeley found that mycorrhizal fungi transported over a third of all the water a plant used during the day. Plants with active mycorrhizal connections could keep transpiring, keep photosynthesizing, and keep growing for 24 to 48 hours longer during drought than plants without them. Now here is the connection that matters for how you water. When you water shallowly every day, the surface stays perpetually wet and the deeper soil stays dry. That is exactly the wrong signal for mycorrhizal development. These fungi thrive when they need to reach for water. Deep watering with dry periods between gives them the conditions they evolved in. So shallow watering does not just weaken your roots, it weakens the entire underground support network your plants depend on. If you are finding this useful, hit subscribe. We break down the science behind gardening every week so you can grow more with less guesswork. Now let me talk about the mistake that catches almost everyone because it is genuinely tricky: overwatering. And the reason it is so tricky is that an overwatered plant looks almost identical to an underwatered plant. Wilting leaves, yellowing, drooping stems. The symptoms are a perfect match, and the natural reaction when you see your plant wilting is to give it more water, which makes the problem catastrophically worse.
Here is what is actually happening. Oxygen moves through water 10,000 times slower than it moves through air. So when you fill every pore in your soil with water, you are suffocating the roots. They cannot breathe. Without oxygen, roots cannot absorb water or nutrients, and they start to rot. Pathogens like Pythium and Phytophthora thrive in exactly these waterlogged, airless conditions. The plant above ground is wilting because its roots are dead or dying, not because it is thirsty. And when you see that wilting and add more water, you are drowning a drowning plant. Here's how to tell the difference. Touch the leaves. If they feel crisp and dry, the plant needs water. If they feel soft and limp and the soil is moist, stop watering immediately. That plant is suffocating, not thirsty. So what does science-based watering actually look like in practice? It is simpler than you might think. First, forget the schedule.
The amount of water your garden needs changes every single day based on temperature, humidity, wind, and how much sun your plants got. On a cool, cloudy day, your garden might need a 1/4 inch of water. On a hot, sunny, windy day, it might need a full inch. A fixed schedule gets it wrong almost every time, overwatering on cool days and underwatering during heat waves. Instead, check your soil. Push your finger about 2 inches into the soil near your plants. If it feels cool and moist, you do not need to water. If it feels warm and dry, it is time. This simple test is remarkably accurate. A researcher at Kew Gardens pointed out that your fingertip detects 3 separate physical properties: thermal conductivity, cohesion, and plasticity, that are all direct indicators of soil moisture. Your finger is a better tool than most cheap electronic meters. Second, water deeply and less often. For shallow-rooted crops like lettuce and radishes, aim to wet the soil to about 6 to 8 inches. For medium-rooted crops like beans and peppers, 12 inches. For deep-rooted plants like tomatoes and squash, 12 to 18 inches. In most soils, this means applying about 1 to 2 inches of water per session, then waiting until the top 2 inches dry out before watering again. Third, get the water where it needs to go. Drip irrigation delivers about 90% of its water directly to the root zone. Overhead sprinklers deliver about 65 to 75%, losing the rest to evaporation, wind drift, and watering areas where no plants are growing. If you combine drip irrigation with 2 to 4 inches of organic mulch, you can reduce your total garden water use by 50 to 75% compared to sprinklers on bare soil. And about that mulch, a layer of organic mulch, straw, wood chips, shredded leaves, does something remarkable. It cuts surface evaporation by roughly 40%, keeps soil temperatures up to 20 degrees Fahrenheit cooler on hot days, and over time, as it decomposes, it increases your soil's ability to hold water for the long term. Every 1% increase in soil organic matter stores an additional 20,000 gallons of water per acre. So mulch is not just saving you water this season, it is building a soil that needs less water every season after. And here is something about specific crops that trips people up. Different vegetables need water at very different times. Tomatoes are most vulnerable during flowering and fruit sizing, and inconsistent watering during those stages is exactly what causes blossom end rot. That is not a disease. It is a calcium transport problem caused by erratic soil moisture. Peppers drop their flowers if they dry out even briefly during bloom. Carrots fork and split when they get a drought followed by a heavy watering because the root tip dies and side branches take over. Lettuce bolts into bitterness after just a few days of water stress in warm weather. Each crop has a critical window, and knowing those windows is worth more than any watering gadget you can buy. One last thing that might surprise you. A little bit of water stress is not always bad. Controlled deficit irrigation, where you deliberately reduce watering by about 30 to 50% during the last 2 to 3 weeks before harvest, actually concentrates sugars and flavor compounds in your fruit. Research on tomatoes found that moderate water deficit increased vitamin C content by 31% and boosted sweetness. The fruit gets smaller, but the flavor per bite goes up significantly. Wine growers have used this technique for centuries. You can use it in your vegetable garden too. So here is the pattern. Deep watering creates deep roots. Deep roots access stable moisture. Stable moisture creates resilient plants that produce bigger, more flavorful harvests with less water and less effort from you. It is really very simple once you understand the biology. Anyone can do this. So now you understand how water moves through your soil, how your roots chase it, and why deep, infrequent watering builds plants that can handle anything your summer throws at them. Next week, I am breaking down what really happens to your soil when you add mulch, the biology that makes it the single best thing you can do for water retention. Subscribe so you do not miss it.